Hello everyone. So in this video I'm going to discuss qualification round 2022 for Google Code Jam. Now I am not good with competitive programming, but for the qualification round you just needed 30 points and I was able to score more than 30. So yeah, I just want to discuss the three problems. They're pretty simple. I know most of them were able to solve it, but still I would like to go over them and see how we could have approached it. Also, I did try the other problem, the chain reactions one. I got the approach, but I wasn't able to complete in time because I started pretty late. But yeah, we will discuss that also later on. But let's go on with the first question. The first one is punched cards. So let me actually remove this part somehow, if I can remove this. I'm not able to move this. Okay, let me increase the screen first and then I will make it a smaller screen. So in this question what we need to do is, it's a very big question, but I'll quickly go briefly over it. So we are given a row. So basically as an input we will just be provided with row and column, and we just need to display how the punching card would look like, right? So for example, if we have 3 rows and 4 columns, we just need to print this out. Now there is one condition that the top left one will always be folded. So because it's folded, now there is one more thing. For each row we are going to use two rows in this case. Like in terms of diagram, if you see, these 2 rows actually display our punching card. So basically the punching card is displayed by this, and you can think of this as boundaries. So this is one boundary, and then we have one punching card row, and then we have another boundary, and then we have one punching card row, and then so think about it. If we have 3 rows, this is one row, this is one row, this is one row, and everything is just split by these boundary things, right? Now except the top left corner, because it's folded, it's given in the question, we need to print 4 dots, otherwise this is our boundary. So the it's basically a question of displaying or printing this out in terms of string. So in this case, this is one row, as I said, this is one row, this is one row. Only the first row will have 2 dots at the start, else it's always the same, right? It's like that. Now in terms of columns, so columns, they are representing this thing, like this dot dot minus this. You can think of it as 4 columns, and then again this is divided by boundaries. So this is one boundary. I'm not able to display it here. Let me maybe draw it out here and then we can see. So think of it like this. This is one dot, this is one dot, plus, minus. Let me zoom in. Yeah, now this is pretty zoom. Okay, so this is minus, and then this is plus, minus, plus, minus, plus, right? And then this is dot dot dot, and then we have plus, minus, plus, minus, plus, minus, plus, minus, plus, right? So basically I took this as columns. So these are our 4 columns, and then everything else which is surrounding it is our boundary. So we just need to print it. Like I just used for loops to print these rows. So you are given R and C, and you just need to print it, right? And it was a pretty straightforward question. I guess everyone was able to solve. See, 94% of the people solved. This was solved by 77%. This was solved by 83%. 19% only solved this, and this was solved by 1%. Yeah, so let's go to 3D printing. So this is also a very straightforward question. What we need to do is, let me actually explain it from the diagram perspective. So let me remove this all. Okay, now in this case we are given, okay, wait, Okay, we are given three printers. One, yeah, so we have three printers as see show it on the screen. Let's say this is printer 1, printer 2 and printer 3. Now each printer has four cartridges, right? So of colors like cyan, magenta, yellow and black. So similarly I can say C1 M1 Y1 K1, C2 M2 Y2 K2 and C3 M3 Y3 K3. So basically we can form any color using these four base colors. Like if I have a combination of yellow or maybe black, it will obviously black. If we have a combination of yellow magenta, it might become a red. So it says here, let's say um, if you want to use red, so use 0 units of cyan, 50,000 units of, or whatever it is, 500k units of magenta, 450k units of yellow and 50k of black, something like that. So whatever it is, we are given these values. For each printer we are given all the four values, that how many units are there left, and now we need to print, let's say a letter, printing a D, letter D. Now we need to print D from all the three printers and they should be of same color, right? So the only way the color will be same if I have equal units of, let's say I want to make a color D of only cyan. So if all of the printers have that minimum value of cyan, that I can use and create using same color. Now there is one more condition, that all the units that you use, that should be equivalent to 10 to the power 6. So let's say if I only want to make a D of yellow color, right? So if my printer 1 has 10 to the power 6 units of yellow, and similarly 2 also have 10 to the power 6 units of yellow, and printer 3 also have 10 to the power 6 units of yellow, then only I can form a yellow. If any one of this printer has less number of yellow units, which is less than 10 to the power 6, then I cannot form a color, a similar color, because I need to print D and it should be of same color from all the printers, right? So the way I solved it was, I'll go to the code. I basically took the minimum, right? So what we can do here is, if we go with the greedy approach, if I take the minimum, like let's say out of the first three printers, if cyan, what is the minimum value of cyan, what is the minimum value for magenta, what is the minimum value out of the three for yellow, and similarly black. If I total them, if it's equal to 10 to the power 6, then I'm confident that even taking the minimum value of one color from the printer which has the minimum value, I'm able to form that 10 to the power 6 number, right? Because that is my condition. Let's say I wanted to form, as I said, I wanted to print letter D with yellow color. So in that case, if one of the printer doesn't have the units required to print yellow color, right? Then I cannot use other printers, because see, other printers are able to, let's say printer 1 and 2 are able to print D in yellow color, but if printer 3 doesn't have enough units, then it doesn't make sense. So what is the bottleneck here? Bottleneck is the printer which has the minimum value of that particular color. So you just take the minimum and go from there, and this would be able to, we would be able to solve this question. Now the third question that I was able to solve was this one. This is also pretty easy in terms of understanding. So what we need to do, let me take this. So we are given some dices. Let's say I have 4 dices. So this is the dice with 3 sides, 4 sides. This is the dice with 10 sides, and this is the dice with, let's say, 7 sides. So if a dice is of 7 sides, then I can pick a number between 1 to 7, right? Similarly, if this is a dice of 10, I can pick between 1 to 10. For here 1 to 4, and for here 1 to 3, right? Correct. So what I need to do here is I have been given dices. Let's say there are n dices. In our case, this is 4 dices. Now I need to I need to pick only one number from each dice, and I need to pick the numbers in such form that, let's say if I pick x from the first dice, then is it possible to pick x plus 1 from the next dice, and then is it possible to pick x plus 2 from the other dice, and then x plus 3 from the fourth dice. So I can only pick one number from each dice, and then it has to be in a consecutive way. So what is the maximum length that I can form in a consecutive way given the number of dices? So let's take an example to understand this. Let me delete all of these. Okay, so if we go down, let's say we are given dices of number 5, 4, 5, 4, 4, 4. Now what I can do here is, let's say I use this 4, I take 1 from this dice, right? Then I remove this. Then I take 2 from this dice, I remove it. I take 3 from this dice, I remove it. I take 4 from this dice because I can take 4, I remove it. And then I take 5 from this dice and I can remove it. Now this dice is left, but I cannot take 5 again because I have already picked 5, and I cannot pick 6 because it doesn't have number 6. So the maximum length that I can form is 1, 2, 3, 4, 5, and that will be our answer. So to solve this, what I did here was I basically sorted the array. So let me show my code. So I sorted the array, and then I greedily picked each number from the beginning from 0 to the size of my dices. And I also checked that if I've already picked a number, like in this R case where I already picked 5, if I've already picked 5, then I don't need to pick 5. So that's how I was able to solve it. So yeah, this was the third one, and for the fourth one, this is a chain reaction. For this question, I guess we need to use some kind of dynamic programming. I'm not sure. So this is more like graph plus DP, I guess, but I'll go over the editorial to see how to solve it, and maybe I can make a video on that later on. But yeah, that's all for this round. Hope you guys like this video. If so, subscribe to my channel, give me a thumbs up, and follow me on Instagram. Thanks for the support.